Well, good morning. We are looking at day 2 or warm-up number 2 of chapter 2 or unit 2, linear functions. So the first one here we're going to start in, this is your warm-up, this is a try on your own. Remember the first one here is combine like terms. So just remember you're just combining like terms. This next one, we have a little bit of distributive property to do. And then combine like terms, so distribute and combine like terms. And this last one is a kind of a combination of those two put together. Remember, this is a -7 that you're going to distribute and then combine like terms. So we're back to this. We're doing the same, distribute and then combine like terms. Remember to watch your signs. Number four, find the area of a rectangular wall that is 8 feet tall. Ooh, that's supposed to be by 12 feet wide. What type of real life situation would you need to know the area for? So first of all, we have to find the area, and then we have to give me a real life experience. So first of all, let's say I have 8 foot by 12 foot. It's a rectangular wall, so we're going to go like this. 12 by 8, and we would multiply those. So for area, because it's a square, it's going to be square, so it's like 12 this way. And then we have, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it'd be like 12 chunks this way and 8 in the other direction. So there would be 2, 4, 5, 6. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. And then we would just cut up all those little squares. Or we could just say 8 times 12, which is 96. So that would be 96, and these are feet, so it's going to be feet squared. That would be the area, because area is equal to length times width. And then give a real life situation. So you tell me, give me a real life situation. The next one's down below, I'd like you to try with no calculator and actually see where you are at. Know what you know what you don't know. So first thing I would like you to do is go through and do your signs. Notice that this is, there's just a -7 minus 11. So it's a subtraction, or minus. This is a +5. This is a take away a -4. This is multiplication because parentheses means multiply. Multiply, and then here's a straight out divide. So do those on your own, please. And then is the relation a function? So is the relation a function? Remember, to be a function, I can have each input has exactly one output. So if my x's repeat, it's probably not a function. But look and see. So look at your x's. If they repeat, write no. If they do not repeat, at this point, write yes. Which functions are non-linear? So I want you to think about what linear and non-linear means. It means, okay, so linear, linear means it would make a straight line. And I will also tell you that linear, so it means a straight line, and it also means my exponent value is 1. Okay, and let's work on that a little bit. Down below, you should be able to tell me if they are functions or not functions based on that vertical line test. So do your vertical, oops. All right, so now we're into today. Today we're going to graph using tables of values. So when I graph using table of values, I want to pick numbers that will fit on my grid, preferably. So we're going to start in, here's my function. So I'm going to write this as my 2x plus 3. You should remember this from pre-algebra. And I'm going to pick numbers. I like, my favorite number is 0. So I'm going to click 0. And then I'm going to go above it and below it. So I'm going to go Negative 1 would be below and negative 2. And then I'm going to go 1 and 2 because there are no fractions in here, so I don't have to worry about the denominator. The denominator here would all be 1. So I'm going to go by 1s, starting at the origin. So starting at 0 something, 0 and then up or down something. So when I plug in, I'm going to start even there. When I plug in that, I'm going to say 2 times the 0 plus 3. So 2 times 0 is 0, plus 3 is just going to give me 3. The ordered pair of x, y is going to be 0, 3. Now to go back and do negative 1, I'm going to say, 2 times negative 1 plus 3. Well, 2 times negative 1 is negative 2. Plus 3 is going to give me 1. So this gives me negative 1, gives me 1. When I plug in a negative 2, I'm going to say 2 times negative 2 plus 3. 2 times negative 2 is negative 4, plus 3 is negative 1. So my ordered pair would be negative 2, negative 1. If I go on the other side, I'm going to have 2 times 1. Oops, I should put my thing. Plus 3. 2 times 1 is just 2, so 2 plus 3 would be 5, so 1, 5. And when I plug in a 2, 2 times 2 plus 3. Well, 2 times 2 is 4, plus 3 would be 7, so 2, 7. So I'm going to plot my dots. So this is my x-axis, this is my y-axis. On this, it means over, right, or left, and up or down. So if you recall, this would be negative 2 means left 2 and down 1. Left 2, down 1. This means left 1, up 1. So left 1, up 1. 0 means I stay the course, stay on, and then I'm going to go up 3. So stay on the y-axis and go up 1, 2, 3. 1, 5, I'm going to go right 1, up 5. Right 1, up 5. 3, 4, 5. And this is right 2, up 7. So up over 2, up there's 5, 6, 7. And I can make a pretty line. Or kind of a pretty line. Now, I'm going to ask, say, is this point a solution? Is it on the line? Well, look, I already used a negative 2. So here's my negative 2. Negative 2 gave me negative 1. So is that what I got? Yes, they're the same. So is it a solution? Yes. And how does it relate to the graph? It's on the line. The next one, it says graph the equation y equals 1/2 x plus 3. Well, this one has a denominator of 2. Okay, so I'm going to say 1/2 x plus 3. And before I told you on the first one that we did, I said the denominator all the way across was going to be a 1. Here, I have a denominator of 2. So I want to go by 2's over here in my x-axis, or my input. I'm going to start with my 0, because I really like 0. It's my favorite number. And I'm going to go above and below. And you have to have at least 3 points. If you only give me 3, that's fine. You don't have to give me 5 at this point. When you get 2 parabolas, we will need to have 5 points. So right now, I could go negative 2 and I could go positive 2. So at 0, that's where I always like to start. At 0, I'm going to say 1/2 times 0 plus 3. Well, 0 times 1/2 is still 0. Plus 3 would give me 3. So the ordered pair here is going to be 0, 3. 0 cross up 1, 2, 3. But now I have to put in the negative 2. So we're going to say 1/2 times negative 2 plus 3. Well, positive and negative makes it a negative, and half of 2 is 1 plus 3. So negative 1 plus 3 would give me 2. So the ordered pair here is going to be negative 2, 2. Down below, if I plug in a 2, I'm going to say 1/2 times 2 plus 3. Well, half of 2 here is going to be 1 plus 3. 1 plus 3 is 4. So it's going to be 2, 4. So I can plot the rest of those dots. I'm going to go -2, 2. So this means left 2, up 2. So left 2, up 2. And this means right 2, up 4. So right 2, up 1, 2, 3, 4. And make a pretty line. Now it's asking me, is the 0.68 a solution? Well, the only way I can actually tell, because it's graphing, and graphing can be kind of sloppy. Not saying that you're sloppy, I'm just saying that it can be kind of sloppy unless you're doing it on a computer, nice and tidy. So we're going to plug in a 6 and see if it works. So we're going to say y equals, actually, it's telling me my y value. This being my x value, this being my y value. I'm saying 8 is equal to 1/2 times 6 plus 3. And we're going to check to see if it works. So what's half of 6? Half of 6 is going to be 3. So 3 plus 3 is 6. 8 does not equal 6, so that's a no. So no, it's not going to be a solution. And how does the point relate to the graph? Well, if it does not work, if it's not a solution, this one was a solution, it's on the lines. This one is not a solution, so it is not on the line. Now we're going to be graphing. Yes, on Monday, actually, we went through and we did vertical and horizontal lines. Remember, I told you if there's only one variable, it's special. So this one has only one variable, and it's y equals 4. So that means that it's going to cross the y-axis at 4. Well, here's my x-axis, and here's my y-axis. It's going to cross the y-axis at 4. So we know it's going to go like this. And my y values are always 4. So 4, 4, 4, 4, 4. So you can pick anything you want to put in here because it's going to go forever. It's going to go to infinity over here and to negative infinity back here. So any number you want to put in. I have my 0, -1, -2, 1, and 2. Sure. And that would be -2, 4, -1, 4, 0, 4, 1, 4, 2, 4. But you should have this similar to what's in our notes from day 1. And then graphing the equation x equals -3. Well, this one's going to, x is always -3. So it's going to crosses the x-axis at -3. So here's my x-axis. It's going to cross the x-axis up and down at -3. So 1, 2, 3, here it is. It's going to be right, oops, right about there. So you can pick again, when you plug in -3, the y value is going to be all up and downs. So you could do -3, -2, -1, 0, 1, 2. It does not matter what you plug in here, any number. So this one, remember, is a horizontal line. And this one is a vertical line. Our third concept, the number of pages a student types is given by the equation. So I'm giving you the equation where t is the number, is the time. So t equals time of typing. And as at most 2.5 hours, graph the function, identify the domain and range. Okay, so we have quite a few little things we're going to do here. I'm telling you at most 2.5. So I cannot put in my time more than 2.5. So t is time. That's like my x-axis, that's my input. And this is my output, number of pages. So if I wrote a verbal model, I would actually say the number of pages is equal to 4 times the number of hours. But my hours has to be less than 2.5. So I'm going to go ahead and put in up to at most 2.5. And then I'm going to scale it back and say, okay, well, let's do 2, let's do 1, let's do, can I do 0 and negative? I can do 0, but can I do negative? Not really. So let's kind of go back here and say 0, let's do 1, 1.5, 2, and 2.5. Notice I'm only giving you the first quadrant, right? So x, oops. My x value could only be 0 or greater. Okay, we're not going to go into the negatives. Oh, crazy there. All right. So then I want you to plug in for that equation. This is for t. So this is my t and this is my p. Okay. This is t and this is p. So if I plug in a 0, if I read 0, I would have 0 pages. If I read 1, I would have 4 times 1, which is 4. 2 would be 4 times 2, which is 8. Here we're going to say 4 times 1.5, which is going to be 6. And here we're going to have 4 times 2.5, which is going to be 10. So now what that looks like is it's not going to continue on. It's not going to have an arrow on either end. Okay, it's going to go just from the 0, 0 to the 2.5. Here's 1, 2 hours, 2.5 hours is 10 right there. And there's this line. Oops, that's not very pretty, but let's do undo. My line is going to be rather straight. That's supposed to be straight. And it's going to end right there. My domain is going to be from 0 to 2.5, and my range is 0 to 10. So 0, 1, 2, what I put in. However, it could be anything that's greater than 0. So I'm going to say my x values are going to be greater than 0. But less than, x is going to be less than 10. Oops, 2.5. So if I know that, I can actually write it as from least to greatest, 0 less than or equal to x, which is less than or equal to 2.5. Because x is greater than or equal to 0, and it's less than or equal to 2.5. My range is going to be the y value. I could write it into 2 separate things, meaning that it's 0 to 10, correct? So the y value is in between 0 and 10. So y is greater than or equal to 0, and y is less than or equal to 10. But I can write that as a full one statement. Y-intercepts and slope. So we're talking about slope. Slope is going to be do you guys remember me talking to you about change of y over change of x? So change of y over change of x, or rise over run. Okay, so we're going to do, and I should put those on separate slides. There you go. We want to read the graph from left to right, from left to right. So a positive slope is going to be slanting upward. The negative slope is going to be slanting downward. Horizontal line is going to be like this, and a vertical line is going to be like this. This one is going to be a y equals some number. This is going to be an x equals some number. And these both have a y equals something x. This will be a positive x, and this is going to be a y equals a negative x. So practice finding slope on each of these. And I'll tell you that if it's slanting up, it's positive. Slanting down, it's negative. Because look at your winking guy. If it's up and down, it is undefined. So this is going to be undefined. If it's like this, oops, if it's like the horizontal, notice we have 0. It's a 0 slope. So find them over here on 1 through 5. Identify here's 1, here's 2, here's 3, here's 4, and then here's 5. Try those on your own. And then we have slopes and rates of change. So we're looking at what they actually mean. We want to understand the meaning. Understand the meaning. So what does slope mean? Okay, well, the slope is going to be like a proportion. Okay, so it's a rate of change. Okay, slope is the rate of change. And it's going to be the y value over the x value. So look at your y value here. It's a total cost, and the x value is your hours. So it's going to be the cost per hour, y over x. So it's going to be the cost per hour. The y-intercept is my total cost, right? So the y-intercept right here is my starting total cost. So it's going to be the starting cost. Oh, I should say, what does it represent as a starting cost? What is the y-intercept? The y-intercept here is right at the 0. So $0 is what it costs to start. Does it represent a proportional relationship? Proportional means goes through the origin. And yes, it does. Why or why not goes through the origin. And number 2, try to work that one on your own. And then this is going to be exercise set number 2. This is what you will do on your own for an assignment. I will see that tomorrow.